మా స్టూడెంట్స్ గుడ్ ఈవినింగ్ మా మీకు సారు మీకు అప్ టు 8 o'clock వరకు సార్ తీసుకుంటారు క్లాసు. ఓకేనా? అంటే మీకు ఎగ్జామ్స్ ఉన్నాయని చెప్పి ఆఫ్టర్ కంప్లీటింగ్ యువర్ ఎగ్జామ్స్ మా సార్ 2 hours తీసుకుంటారు. ఓకేనా? మీకు ఎగ్జామ్స్ ఉన్నాయని చెప్పి సార్ రిక్వెస్ట్ చేసుకున్నాం సార్, లేకపోతే సార్ 2 hours తీసుకునే వాళ్ళు. ఈ 3 days మా, ఇంకా నెక్స్ట్ వీక్ ఉండదు. గుడ్ ఈవినింగ్ సార్. చెప్తున్నారు సార్, యువర్ వాయిస్ ఈస్ నాట్ ఆడిబుల్ సార్.
Hello?
Sir.
Okay now, madam? Okay now, madam?
Okay, now okay, sir. Now okay, sir.
All right, right. I'm going to take class today and Wednesday and Friday.
And no, sir.
Okay,
today, Wednesday, Friday, yes, sir. 7th, 9th, 11th. Okay.
Okay.
1.5 hours, sir. 3 days.
1.5 hours. Okay.
Okay, sir. Okay, thank you, sir.
Okay, shall I start?
Yes, sir.
What about the screen, madam? Screen okay?
It's okay, sir.
Right. Okay, good evening to all of you. Let me continue my lecture in linear algebra. Just wait, please. Hello? Am I audible? Hello, am I audible, please? Anyone of you, please?
Yes,
Hello?
sir.
Okay, correct. Let me start. The continuation of my previous lecture. Linearly independent, linearly dependent vectors. I have already used these words. Let me explain from the basics what is dependent and independent from the definition, because you require the definition also to answer certain bits. The definition: the vectors x1, x2 and so on xn are linearly independent. Here vectors means, vector means ai plus bj plus ck, but any row or row vector, row vector or column vector in matrices. For example, this x1 can be a1i plus b1j plus c1k. So we write it as simply a1, b1, c1 as column or row. Similarly, x2 is a2, b2, c2, maybe column or row. Okay. Therefore, the vectors are linearly independent if I have taken n vectors. a1 x1 plus a2 x2 and so on an xn equal 0. 0 vector it is, please. Multiply the vectors with scalars and equate 0. This implies this a1, a2 all are zeros. Whenever this linear combination equal to 0 matrix, means 0 vector, gives all the scalars are 0, then we say that the given vectors are linearly independent. I think many of you may not follow it. After example, it will be very clear to you. Otherwise, they are linearly dependent. Now, let me explain these words. Suppose among this a1, a2, an, suppose a1 not equal to 0. When a1 not equal to 0, from this, you can write a1 x1 equal to minus of this, standing right side. Then x1 equal to minus 1 by a1 times you can write. Then x1 can be written as minus 1 by a1 times a2 x2 plus a3 x3 and so on an. From this you can write. Suppose this equal to 0, then x1 can be written like this. The same thing you can write like this. You can write this only when a1 not equal to 0. Suppose a1 equal to 0, you should not write like this, please, because by 0 is infinite. It is not defined. So when a1 not equal to 0, you can express x1 like this. Means if you know x2 to xn, you can get x1 from it. Means x1 depends on the remaining vector. When a1 not equal to 0, x1 depends on the remaining vector. Means you have one dependent among these n. Automatically, these are called dependent, linearly dependent. Suppose a1 equal to 0, then you should not express x1 like this. Suppose a2 not equal to 0, you can write x2 in terms of remaining. Then x2 depends on remaining. Depends means they are linearly dependent. Suppose a1, a2 both are 0, but a3 not equal to 0. Then you can write x3 in terms of remaining. x3 depends on remaining. Okay. Suppose a3 also 0, a4 also 0, and so on. A and all are 0. Then none of the vectors can be written in terms of other. Means no vector can be written in terms of other when all the coefficients are zeros. Then we say that no vector depends on remaining means all are independent. I think you got the concept why we use the word independent. Okay. If all are 0, none of the vector can be written in terms of remaining. Hence, they are independent. They won't depend on others. Okay. Let me explain with examples. Here I am explaining with remarks. Here n stands for number of vectors, x1, first x2, and so on xn, n vectors. And m is the dimension of vector, maybe 2 or 3 like it. For example, n equal to 1, m equal to I have taken. Means I am taking only one vector. Dimension is 2. Example, first one, 0 vector, which is 0 vector. We call 0 vector. I have taken only one vector. The dimension is 0. 0i plus 0j, you can think. Now, this 0 vector is linearly dependent. Why? Observe it. Suppose a1, x1. Here x1 is 0, 0. a1, x1 is 0 vector. This implies a1 should be 0. a1 into 0 is 0. a1 into 0 is 0. a1 should be 0 is wrong, please. a1 should be 0 is wrong. a1 need not be 0 also. a1 need not be 0. a1 need not be 0. a1 need not be 0. Means you have a non-zero quantity like this. Means 0, 0 vector is dependent. It's dependent, linearly dependent. Dependent means linearly dependent because a1 is non-zero. Next example. The second example, non-zero vector. I have taken only one vector, dimension is 2. 1, 2. Now we check whether it is dependent or not independent using the definition. A1 into the given vector 1, 2 equal to right side 0. 0 vector, please. 0 vector. From it, a1 equal to 0, 2a1 equal to 0. a1 equal to 0, 2a1 equal to 0. I have two equations. a1 equal to 0, 2a1 equal to 0. Which is possible only when a1 equal to 0. Which is possible only when a1 equal to 0. a1 should be 0. Means, from the definition, from left side, you are getting a1 should be 0. Means, 1, 2 is linearly independent. It won't depend. It's independent. Next. Suppose I am taking only one vector, but the dimension is 3 now. Dimension is 3. Again, I am explaining. 0 vector, triple 0, 0i plus 0j plus 0. It is dependent, very clear. From the same logic, a1 triple 0 here, triple 0, a1 need not be 0. Whereas non-zero vector, another one, non-zero vector, for example, 1, 0, minus 2 is independent. Please observe, zero vector means all are zeros. Non-zero vector means at least one entry not equal to 0. Of course, it may be 0. At least one entry not equal to 0. It is independent, made very clear. For example, a1 into 1, 0, minus 2 equal 0, 0, 0. That happens only when a1 equal to 0. Only when a1 equal to 0. Hence, it is independent. Hence, any zero vector is always dependent. Non-zero vector is always independent. When you are talking only one vector, please. Only one vector. Next. Now I am taking two vectors and the dimension is 2. Two vectors. Each of the vector is of dimension 2. Example, I have taken 1, 2 is one vector, 2, 4 is another vector. I have taken two vectors, dimension is 2, 1i plus 2j, 2i plus 4j. Then I want to check whether these are linearly independent or not. So a1 x1 plus a2 x2 equal to 0. a1 x1 vector plus a2 x2 vector equal to 0 vector. Now observe a1 a2 values. Suppose a1 0 a2 0, definitely it has. Suppose a1 0 a2 0, definitely you will get 0 0. Is there a possibility of getting non-zero values for a1 and a2? You have to think. a1 a2. If you observe 2 4 is nothing but multiples of 1 2. 2 1s are 2, 2 2s are 4. Means the second vector depends on first. Second vector depends on first, means dependent. From the definition, how? Observe it. This a1 you can take 2 and a2 you can take minus 1. Observe it. a1 equal to 2 and a2 equal to minus 1. You have non-zero possibility is there. Whenever non-zero possibility is there, of course a1 equal to 0, a2 equal to 0 also satisfies. Whenever non-zero possibility is there, immediately they are dependent. Here 2 4 depends on 1 2 or 1 2 depends on 2 4. You can think these two are linearly dependent because of non-zero. a1 a2 not 0 are dependent. Next example. I have taken two vectors. One is 1 2, the other is 3 2. Now observe. Now I want to check this from the definition. a1 into 1 2 plus a2 into 3 2 equal to 0 0. Means here a1 plus 3a2 equal to 0 and 2a1 plus 2a2 equal to 0. I need a1 a2 values. We try for non-zero values for a1 a2. When a1 a2 0, automatically it holds. We try to get non-zero values. Here it is impossible to get non-zero values for a1 a2. It is impossible to get non-zero values for a1 a2. a1 a2 should be 0. Why it is impossible, I will explain later, please. I want to explain just a definition. It is impossible to find a1 a2 non-zero. So whenever a1 x1 plus a2 x2 equal 0 vector, then both the scalars should be 0. Means none of the vector can be expressed in terms of the other. Means they are independent. Next, let me explain these two-dimensional through the graph, x-axis, y-axis. Now, this is a vector 1, the height is 2. 1 2 vector it is from origin, 1 2 vector. And 2 4 vector, it is 1 2, 2 4. Please observe, it is 2 4 vector. And the same direction you are getting. This 1 2 and 2 4 are dependent. Please observe, dependent. It is 2 times. Scalar multiple of the other, they are dependent. Now 3 2. 3 on x-axis, 2 on y-axis, vertical. This is 3 2 vector. Now observe 1 2 3 2 are independent. You can't get 3 2 from 1 2 using scalar multiple. 1 2 3 2 are independent. Next, n equal 3, m equal to 2. Now observe, I have taken n equal to 3 now. But m value 2 means dimension is 2, but I am taking 3 vectors. First vector, second vector, third vector. Now observe this one. 1, 2, 3, 2 are independent, but 1, 2, 3, 2, 4, 4. Now we use the definition. Don't think only the graph. What is the definition? A1 x1 plus A2 x2 plus A3 x3 equal to 0 we take. We try to get non-zero values. If you are unable to get non-zero values, definitely they are independent. Now observe it. A1 x1 plus A2 x2 plus A3 x3 equal to 0. Now can anyone give A1, A2, A3 non-zero values, please? A1, A2, A3 non-zero values. Can you give A1, A2, A3 non-zero values by observing? Just observe A1, A2, A3.
Minus 1, minus 1, 1.
Minus 1. A1
Minus
value?
1, minus
Okay.
1.
A1 value minus 1. A2 value?
Minus 1.
Minus 1. What about A3 then?
1.
1. Very good. Very good. Nice observation. Minus 1, plus 1. Minus 1, plus 1. So you can find non-zero values, or you can give 1, 1, minus 1. I'm giving 1, 1, minus 1. The same as minus 1. You can give non-zero values, means they are dependent or independent. Please tell me. When you are able to give non-zero values, so they are dependent or independent, please. Please give me the answer. Dependent or independent?
Dependent.
Dependent. Very good. Because if all are 0, independent. All are coefficients are 0 means if all the coefficients are zeros, none of the vectors can be written in terms of other. They are dependent. So if you observe this 1, 2, 3, 2, and another vector 4, 4 somewhere, they are dependent. Okay. When you have only 2 vectors with 2 dimensions, you can easily observe scalar multiple or not. When you have more vectors, you cannot observe. Next example. I have taken again 3 vectors with dimension 2. The next example. Now observe A1 x1 plus A2 x2 plus A3 x3 equal to 0, 0. Now, can you give A1, A2, A3 non-zero values? You need not give all non-zero, at least one non-zero, please. At least one non-zero. Can anyone please? Please give me A1, A2, A3 non-zero. At least one non-zero among A1, A2, A3. Which satisfies this one? 1, 2, 2, 4, 3, 2. Anyone please? A1 value, A2 value, A3 value. 1, 2, 2, 4, what happens? These 2 times. What about this one? You can take 0, A3, 0, no problem. A1, 2. 2 times the first vector is second. 2 times the first vector is second. The third coefficient I have taken 0, no problem to us. So I have non-zeros here. Not all 0, not all 0. I have non-zero. Hence, they are dependent. It depends on it. One vector depends on the remaining. May not depend on all. If you are able to find at least one vector which depends on remaining, may not depend on all, they are dependent. Not all 0. Not all 0. Hence, dependent. Okay. Next. You may be worried how to check this A1, A2, A3. I will give the procedure how to identify dependence, independence later. First, you should be familiar with the definition. Next, n equal 3, m equal to 2. Over. Next, I am giving n equal to 2, m equal to 3. I have taken 2 vectors, but dimension is 3 now. 1, 2, 3 is 1 vector, 2 4s. I have taken 2 vectors with dimension 3. I plus 2j plus 3k, 2i plus 4j plus 6k. Now tell me dependent or independent. Just observing you can tell. From definition, it is a1 x1 plus a2 x2 equal to 0. Can you give a1 a2 non-zero? At least one non-zero, please. Anyone, please? Please. Give me non-zero values. Anyone, please? Please respond.
-1.
A1 value? You can
2.
give
-2.
my A1 value. What is A1 value? You are getting 2, 4, 6, 2 times. 2 ones are 2, 2 twos are 4, 2 threes are 6. Very clear to us. A1 value 2. A2 value -1. So I can give non-zero values. So it depends on it. Depends on it. Scalar multiple. When you have two vectors, you can easily observe. That's scalar multiple. When you have two vectors, more than two vectors, it becomes difficult to identify. When you have only two vectors, you can easily observe with any dimension. Now observe 1 to 1, 3 to 1. 1 to 1, 3 to 1. Now observe A1 1 to 1, A2 3 to 1. Here A1 value 0, A2 value 0 should be 0. Without zeros, you won't get this. A1, A2 should be 0. Hence, these are independent. How I know A1, A2 should be 0? I will explain later, please. I will explain later. Of course, with two vectors, you can always observe not scalar multiple. Whenever not scalar multiple, with two vectors, you can easily tell. Now, n equal 3, m equal 3. I am taking three vectors, each of dimension 3. Example 1, 2, 3, 2, 4, 6, 5, 6, 3. Now tell me, dependent or independent? You can easily tell. Dependent or independent?
Dependent.
Dependent, because second vector depends on first. It is scalar multiple. If you are able to find at least one dependent, automatically dependent. Here A2, A1 value 2, because A1 value 2, A2 is -1, because 2 times this is this, and A3 you can take 0, no problem. Already 1, 2, 3, 2, 4 are dependent, automatically this is dependent. Are dependent. The next one more. Now observe, now you will get concept from it. 1, 0, 0, 0, 1, 0, 0, 0, 1. A1 x1 plus A2 x2 plus A3 x3. Now, can you give A1, A2, A3 non-zero for it? Anyone? Is it possible to give A1, A2, A3 non-zero? So that the sum is 0? Is it possible? 1, 0, 0, 0, 1, 0, ijk. It is nothing but. What about A1, A2, A3 values here? Please. A1, A2, A3 values?
0.
Should be 0. Should be 0. Without zeros, you never get. Means they are independent.
Independent.
IJK are independent. This is the concept which we require. Don't think always IJK. You can use any other vectors also. IJK are independent. IJK, these are independent because of this reason. Okay. Now I'll give some more on 3 and 3. Third example, 1, 2, 1, 3, 2, 1, 5, 6, 3. Now I'm giving some complicated examples, of course. Observe it. A1 x1 plus A2 x2 plus A3 x3 equal to 0. Here, A1 value 2, A2 value 1, A3 value -1. This is my observation, please. A1 value 2. 2 times first plus second minus third means 2 into 1 plus 3, which is 5. 2 into 2 plus 2, which is 6. 2 into 1 plus 1, which is 3. This is my observation. That's why 2, 1, -1. 2 times first vector plus second vector gives third vector, means minus of it, which is 0. This is my observation. If you are able to observe, okay. Hence, I have non-zero, means these three are dependent. If you observe, none of the vector is scalar multiple of another, but they are dependent. They are connecting with an equation with non-zeros. They are dependent because the third vector you can obtain 2 times first plus second. Okay, one more example. 1, 1, 2, 2, 4, 6, 3, 2, 5. Please observe 1, 1, 2, 2, 4, 6, 3, 2, 5. Now observe this. A1, 1, 1, 2, A2, 2, 4, 6, A3, 3, 2, 5, 0, 0. Now I try to get A1, A2, A3 non-zero values. It is further complicated problem. With my experience, I am telling here A1 is 8, A2 is -1, A3 is -2. With these values, with A1, A2, A3 non-zero, you can get zero vector. You can observe 8 times first vector equal to second vector plus 2 times third vector. You can observe by setting right side. 8 times first vector is same as second vector plus 2 times third vector. Means now you can observe 8 ones are 8 here. Here 2 plus 2 into 3. 2 plus 6, which is 8. Next, 4 plus 4, which is 8. 6 plus 10, which is 16. 8 to 16. 8 to 16. 6 plus 10. This is my observation. How to think? I will explain later, please. What about these are dependent? Next. Again, another example. 1, 1, 2, 0, 0, -1, 2. A1, 1, A2, 1, 2, 0, A3. Here, it is impossible to give A1, A2, A3 non-zeros. Should be zeros. Means these three are dependent or independent? Please tell me. Please. A1, A2, independent. Independent. Unable to get. Independent. Okay. Okay. Now, whenever certain vectors given, number of vectors given with any dimension, how to tell dependent or independent, that is important to us, please. I am giving one note to you. The m-dimensional vectors, x1, x2 and so on, xn, are linearly independent if and only if rank of, I am using rank now, rank of these column vectors x1, x2 and so on, xn equal to n. I have n vectors. Each vector is of dimension m. Suppose if you form the matrix with these column vectors, calculate its rank. If rank equal to number of vectors, then they are linearly independent. Otherwise dependent. Rank equal to number of vectors, please. Now we know how to find rank. It becomes easy to find rank of a given matrix. So let me explain how these three examples, how to answer dependent or independent with this, without bothering about this A1, A2, A3. Of course, it is the definition. We require definition also for certain problems. Now let me explain the fourth example here. 1, 1, 2. It is x1. 1, 1, 2. 2, 4, 6 is x2. 3, 2, 5 is x3. x1, x2, x3 columns. I formed a matrix. Fourth example, please. This fourth example. I formed a matrix because it is 8 minus 1 minus 2. Not possible to think. I formed a matrix. Now I require the rank of this one. How to find rank of this one? You know the procedure. You can reduce the echelon form, or directly you can use dependency and independency. Okay, now observe this. R1 plus R2. I observe this, please. Of course, you can cancel this with 2. 2 1s are 2, 2 2s are 4, 2 3s are 6. Then we will get 1, 2, 3, but it won't help you. If you observe 1 plus 1 is 2, 2 plus 4 is 6, 3 plus 2 is 5. Therefore, the third row depends on first and 2. Dependent, delete. I have already explained how to find rank. This is my observation. If you are unable to observe, use reduced echelon form. Therefore, this depends on first and second dependent delete. Okay. Now, I know the rank of this one. Rank is 2 because I applied the rank definition now. AD minus BC. It has 1 second order non-vanished minor. 4 minus 2 not equal to 0. Or you can take 4 minus 12 not equal to 0. You have at least 1 second order non-vanished minor after deleting it. So its rank is 2. Now observe fourth example. Here rank is 2. Its meaning I have rank is 2, but I have 3 vectors. Rank is 2, but I have 3 vectors. Means dependent. They are not equal. In other words, among 3 you have 2 independent vectors. Among 3 you have 2 independent vectors. One depends on remaining. Its meaning is that rank is defined as number of linearly independent vectors. Among 3, only 2 are independent. That's why these 3, when you are taking, dependent. Okay, whenever rank equal to number of vectors, they are independent, otherwise dependent. Okay, now coming to fifth example. Now observe, without bothering 8 minus 1 minus 2. Okay, to find rank, you can use row or column vectors, row or column operations. Now coming to fifth example. X1, X2, X3. X1, X2, X3. Now I require rank of this one. Now observe how to find rank of this one. How to find rank of this one? You can observe the dependency, any dependency like this or scalar multiple. Unable to observe. Then you can proceed as usual R2 minus R1 to get 0 here. And to get 0 here, R3 minus R1. I want to reduce the echelon. This here 0, here 0. Therefore, R2 minus R1, R3 minus R1. The first row is just copy and paste. Now, R2 minus R1 gives 1 minus 1, 0. 2 minus 1, 1. Minus 1 minus 0 is minus 1. Now, coming to third row. R3 minus R1, 1 minus 1, which is 0. 0 minus 1, which is minus 1. 2 minus 0, 2. I applied this. Now, it is not echelon form. But I can tell directly its rank, of course. I am using one more operation to reduce to echelon form. Now you can go like this. Now R3 plus R2 to get 0 here. R3 plus R2. Now first 2 rows just copy paste. And third row R3 plus R2. 0 plus 0, minus 1 plus 1, 2 minus 1. Now it is an echelon form. What is the rank of this one? Please tell me. What is the rank of this? It is an echelon form. Number of non-zero rows. What is the rank? Please. What is the rank? Rank 3. Therefore, rank of this one is 3. Rank of this is 3. Rank of this is 3 because they are equivalent. One matrix obtained from the other, then we say equivalent. The rank is 3. For fifth example, here rank is 3. Rank equal to number of vectors. 3 vectors given, rank is 3. Hence, independent. A1, A2, A3 should be 0. Should be 0. Without zeros, you never get this is 0. In other words, rank is defined as number of independent vectors. I have 3 independent vectors. That's why independent. Whereas in fourth example, I have 2 independent vectors among 3. One depends. That's why dependent. Okay. Similarly, you can observe third example also. 1 to 1, 3 to 1, 5, 6, 3. I observe 2, 1 minus 1. Without observing also, you can tell using rank. Now observe 1, 3, 5, 2, 2, 6, 1, 1, 3, 2, 2, 6, 2, 1, 1, 3. You can easily observe this is nothing but 2 times the third row. This is 2 times the third row. It depends on third row. You can delete it. Dependent, delete. Dependent to find rank, dependent, delete. You can think it is a matrix containing these 3 columns. Dependent, delete. Now in the remaining, use rank definition directly. You have second order minor, non-vanished minor, AD minus BC. 1 into 1 minus 1 into 3. 1 minus 3 not equal to 0. You have second order non-vanished minor after deleting it. Means its rank is 2. You have second order non-vanished minor. Its rank is 2. Using rank definition, AD minus BC not equal to 0. So rank is 2, but number of vectors given to you 3. So dependent. You have only 2 independent vectors among these 3. What about the third one? Should depend on remaining 2. Okay. I think this definition helps you a lot to decide whether given vectors are linearly independent or dependent. Just to rank. Rank helps us. Next, another example. Now observe, I have taken 3 vectors. Vector means any column vector, any column matrix is a vector, or row matrix is a vector. It contains only one column, that's why vector. These are column vectors. How many vectors given to us, please? How many vectors? How many vectors given to us? Please, how many vectors given to us? How many vectors given to us? Just count and tell me. How many vectors? Please respond.
3 vectors.
3 vectors given. Please respond, please. Okay, I want to check independent or dependent. Okay, to check independent and dependent, a1 x1 plus a2 x2 plus a3 x3 equal to 0 I am not using. I am forming matrix and its rank. 1, 2, 2, 3, 1, 2, 4, 5, 3, 6, 10, 13. Now I require rank of this one. To find rank of this one, what you observe? Here 2 times 2 multiples. Of course, it depends. You can delete. It depends on first row. You can delete, or directly I am converting to echelon form to find rank of this one. R2 minus 2R1, R3 minus 2R1, R4 minus 3R1. Okay. Now the first row remains same. Now R2 minus 2R1, 2 minus 2, 2 minus 2, 6 minus 2 into 3 means 6 minus 6, which is 0. Depends, that's why deleted zeros. Now R3 minus 2R1, 2 minus 2, 4 minus 2, which is 2. 10 minus 2 times 3, 10 minus 6, which is 4. Now R4 minus 3R1, 3 minus 3, 0. 5 minus 3, 2. 13 minus 3 3s, 13 minus 9, which is 4. Now observe, you can easily tell rank here because the last row, this is 0 row, you can delete, and also the last one is nothing but R3. Fourth row is nothing but R3. One time R3. Fourth row is one time R3. So you can delete these 2. Now you can easily tell the rank of the matrix. What is the rank? Please tell me. You can use rank definition. What is the rank of this, please? What is the rank of this matrix? Anyone, please?
2, sir.
Rank is
2.
2. Very good. Because non-vanished minor AD minus BC 1 to 2 minus 0 into 1 is not equal. You have second order non-vanished minor. Its rank is 2. Now what about the problem? Are they independent or dependent? The given 3 vectors. Please tell me.
Dependency.
Dependent, because you have only 2 independent vectors among 3. But the number of vectors given to you is 3. Are linearly dependent. Okay. Now I am forming another problem on it, please. The same problem. Suppose in place of this 13, to save time, I am taking like this. In place of 13, 14 given, please. Please observe this. Suppose this is 14 given. What happens here? This is 14 then. Now when you are calculating, it affects on 4th row. So I am deleting these, please. Now 14 minus R4 minus 3R1. 14 minus 9 now, which is 5. Now observe, I am showing with the green color. shade, green color shade. Now, this you cannot delete the third row. Previously 0240, but 025 you cannot delete. So I'm removing this piece. I'm removing this. Now, can anyone tell the rank? What is the rank? Now tell me the rank. Not echelon form. What is the rank? I already given clue how to find rank.
3.
3. Very good. How can you tell rank 3? How can you tell rank 3?
Independent rows.
Independent row. No. Here, when you calculate the determinant of third order 100 into determinant of 2425, please. It is not echelon form. Ignore the second row. You remain with 113, 024, 024. It's a determinant when you calculate using first column 1 into determinant of this one. Determinant of 2425, which is AD minus BC. I just observed AD minus BC not equal to 0. 10 and 8 are not equal. Hence, determinant not equal to 0. Third order determinant not equal to 0 means you have third order determinant not equal to 0. From rank definition, it is 3. You have third order non-vanished minor. Its rank is 3. So when I use this green colored, what happens to me? My rank is 3 now. These two are equal. Then the given are linearly independent. I think you followed the same vector just by changing this independent. Previously dependent. Okay. Next example. Now I have given 4 vectors, each of dimension 3. Now tell me dependent or independent? Linearly dependent or independent? If you follow the definition, it becomes very easy to answer this. Just by observing the problem, I can tell answer immediately. Can anyone? Just by observing the problem, I can tell answer. Anyone, please? Are you getting any idea? Just by seeing the problem, immediately I can tell the answer without doing any calculation. How can I say? Please observe this. Are linearly dependent. How can I say linearly dependent directly? Anyone? Please. How many vectors given to us? How many vectors given to us, please? Number of vectors. How many?
4.
4. When you are finding rank, what happens? What is the order of that? What is the order of the matrix? Please tell me the order of the matrix.
3 cross 4.
3 cross 4. Very good. 3 cross 4. Order is 3 cross 4. From the rank definition, can I get rank 4?
No, sir.
No. Because 4 cross 4, I can't get it. What is the maximum possible rank? Maximum possible rank?
3.
3. Therefore, maximum possible rank is 3, whereas given vectors are 4. They are not equal. Without finding rank, I can tell dependent. I think you got the meaning. How I can got it. Just by observing, I can tell like this. Because rank number of vectors are 4. I cannot get rank 4 from it. I cannot get rank 4. Maximum is 3 only. Okay, I cannot get 4 independent vectors like this. Okay. Now observe, any subset of linearly independent is linearly independent. Any subset of linearly independent is linearly independent. Means, for example, in the first example here, these three are linearly independent when I take 14. Take subset means the first two. If you take first two, these are independent. Or first and three independent. Or second and three independent. Or take only one vector independent. Means any subset. Whenever a set is independent, subset is also independent. Okay. Any superset of linearly dependent is linearly dependent. Superset now. Suppose I have a set which is linearly dependent. If we add some more, dependent only. Superset. Any subset of linearly independent set is linearly independent. Any superset of linearly dependent set is linearly dependent. Adding some more, still dependent. I have a set independent, subset definitely independent. Okay. This is about linearly independence and dependent using rank. And also the definition you should know. A1x1 plus A2x2 and so on, an xn equal to 0 implies A1, A2, In should be 0, then independent. Okay. Okay, now we go to the next one, next topic. System of linear equations. System of linear equations. Now I have taken an equation which is linear equation. Now I have taken another equation. It is another linear equation. Now these two together we call system. System of linear. I have taken a system of linear equations. Maybe one or more linear equations. Now what I require is x comma y values which satisfy my system. Means satisfying all the equations in the given system. Now I want to explain through graph. X plus y equal to 1. It is a straight line, we know it. To draw it, I need 2 points on it. 1, 0, 0. 1, 0 is here, 0, 1 is here. You can draw it. This is x plus y equal to 1, the line. Now x plus y equal to 0, it passes through 0 plus 0 is 0. And x value 1, then y value minus 1. 1 minus 1. 0, 0, 1 minus 1. So it is another line. Please observe 0, 0, 1 minus 1. Now this black colored gives black, blue colored gives blue color. Now can you give x comma y values which satisfy both the equations simultaneously? Can you give? Is it possible to give x, y values which satisfy both in this system?
No, sir.
No. Hence, this system doesn't have any solution. We say simply no solution for this system. Next, another example. X plus y equal to 1. I am explaining the concepts first, please. Later we go to simple problems and then complex problems. Now, x minus y equal to 0 I have taken now. Now, this is another linear system I have taken. Now x plus y equal to 1. It is the same black color line because it passes through 1, 0 and 0, 1 points. Now x minus y equal to 0 passes through 0, 0. 0 minus 0, 1 minus 1 also 0. Nothing but y equal to x. 0, 0, 1 half of 1, 1 and so on. This is half of course. Okay. Now I require x comma y values which satisfies both the equations. Can I give? Anyone tell please? X value, y value, which satisfy both the equations. Can you give? What are those values? What is x value, y value? What is point? Half plus half is 1. Half minus half is 0. We have only one solution, that is half comma half, of course. 1 by 2, 1 by 2. This is 1 by 2, 1 by 2. You have only one solution for the system. Next, another one. X plus y equal to 1. The same black color I am taking. The second one, blue color, 2x plus 2y equal to 2. Of course, you can cancel, but I am giving as another equation. Of course, the second equation depends on first. Now observe. the black colored, the blue colored x comma y values which satisfy the second equation. You get the same points on the black color, blue and black overlap. How many solutions are there? All points on these lines are solutions. You have infinite solutions. Infinite solutions. Now I am going to do another. X plus y equal to 1. The same black color. I am changing the blue color. X square minus y equal to 0, please. X square minus y equal to 0. X-axis, y-axis. Now x plus y equal to 1. It is a straight line passes through 1, 0, 0, 1 point. Of course, it passes through half, half also. Half plus half is 1. 0.1, 0.9 is also 1. Now, I require x square minus y equal to 0. Please observe, this is nothing but y equal to x square. Y value x square means x square is always positive. X square never be negative for any real x, please. Real numbers we are talking. Don't tell me y square equal to minus 1 which is negative. I require real values. Y equal to x square. X square is always positive. Y value always positive. Y cannot be negative. Y cannot be negative. It is a parabola like this, please. Y cannot be negative. Y is only positive. X can be positive or negative. Okay, this is a parabola. How many solutions are there for this system? Please tell me by observing the graph. How many solutions? Please. How many solutions are there for this system? How many solutions are there? Please respond.
2.
2 only, right? Very good, very good. You have only 2 solutions. Now, if you observe, it is parabola just bends, remaining are straight. Now, it is a non-linear system. The last one is non-linear because of the square. Now, the first 3 are linear systems. We are interested in linear systems.
No, non-linear.
Whenever you have linear system, the solution, you have only 3 possibilities. No one or infinite. The linear system never possesses exactly 2 solutions or exactly 5 solutions.
Yeah.
Either no, one or infinite. Every linear system has only 3 possibilities. No one or infinite. It is non-linear. Because of square it bends. Okay. To explain linear, I have taken non-linear also. Now the words. Consistent.
ఎలా సెట్ చేసుకోవాలి అబ్బో నాకు గంట పట్టదు తెలుసు సెట్ చేసుకోవడానికి అన్ని
Consistent means has at least one solution.
అన్ని మెయిల్ కి బ్యాకప్ కొట్టినా ఇప్పుడే
Has at least one solution. If you have at least one solution, we call consistent. Here, the second or third, these 2 are consistent. The first one is not consistent, we call inconsistent. The words I am explaining, consistent and inconsistent, has no solution. Of course, the last one is consistent, 2 solutions, but it is non-linear. We are not interested in this topic. Now observe again. X plus y equal to 1. What it represents, please tell me. Please respond. I'm going to explain very basic concept, very interesting also, please. What it represents, please, anyone? What it represents geometrically? X plus y equal to 1. What it represents? Please tell me. Geometrically, what it represents?
9.
It is a line, straight line, okay? You are telling straight line. I will show it is false. You may be wondered, I will show, please. You are telling it is straight line, I will show it is false. Please listen it. You are telling like this, okay? X, Y. How you are telling straight line? You are taking points on it. The values which satisfies this equation. For example, 1, 0. 1 plus 0 is 1. 0, 1. 0 plus 1 is 1. Another one, half, half. I have taken 3 points, for example. Like this, you have many points. When you plot all these points, you will get this. 1, 0, half, half, 0, 1, and so on. Okay. Even minus 3 plus 4. Minus 3 plus 4, which is 1. Here you have. You have infinite point. You are telling a straight line. Okay. Now I am showing it is not straight line. How? Observe it. Shall I write x plus y equal to 1 as x plus y plus 0 z equal to 1? There is no wrong in it. There is no wrong. It is same as this one, please. It is same as this one. For example, I have 10 rupees in my pocket. I have 10 rupees in my pocket. Now I am telling I have 10 plus 0 rupees in my pocket. 10 plus 0 rupees in my pocket. There is no wrong in it. Its meaning is same. Therefore, x plus y equal to 1, meaning is same as x plus y plus 0 z equal to 1, because 0 z is always 0. Okay. Now observe. X axis, y axis, z axis. Please, I am drawing 3D here. It is same as this one. Now the points which satisfies this equation I am taking. 1, 0, 0. Z value 0 I am taking. If you substitute here, you will get 1 only. 1 plus 0 into 0, which is 1. 0, 1, 0. Z value 0. It also satisfies. 0 plus 1 plus 0 into 0. Now half, half, 0. The same points with Z value 0 I have taken here. Because 0, 0 are 0. Now we plot all these points. Get the height is 0 here. We plot all these points, you will get this line. We plot all these points, you will get this line. Okay. Don't think these are the only points. I have some more points. For example, I am taking 1, 0, 1. It also satisfies, please observe, 1 plus 0 plus 0 into 1, which is 0 into 1 is 0. Here 1 plus 0 is 1. Now Z value I have taken 1. Similarly, 0, 1, 1. Z value I have taken 1, but 0, 1. The same 0, 1, Z value 1. Z value. It also satisfies. Similarly, Z value 1, but half I have taken. These 3 points also satisfy the same equation because Z value 1. Now, if you plot all these points, where do you get? The same points, height 1 now, Z value 1 now. You will get a line at 1 height, please. This is a line. At 1 height, you will get line front. It will come front, not on Z axis, of course. Similarly, 1, 0. Now I am taking Z equal to half. The same 1, 0, Z equal to half. 0, 1, Z value half. Half, half, Z value half. The same points with Z equal to half. If you plot all these, where do you get? The same line, but height half. You get another line. Like this, as Z varies, you are getting different points at different heights. These are the 9 points I showed. Not only 9 points, you have infinite points. Row wise or column wise, you can expand. If you plot all those points, what it forms? Here, straight line. If you plot all those, it forms. What it forms? Please tell me. What we call? Please. If you plot all these points, it is same as this equation. What we call? Does it straight line? Please, any one of you, please. When you plot all these points, it will form like this. What we call this figure? Please, what we call? All the points. Where do they lie? Where do the points lie, please? Where do these points lie? On a straight line or on a plane? Please tell me.
Plane, sir.
On a plane means all the points which satisfy this equation forms a plane equation. Therefore, this equation is a plane, not a straight line. Please. Followed? Therefore, x plus y plus 0z equal to 1. 0z is nothing but it is a plane, not a straight line. Which one is correct now? Tell me. Straighten or plane? X plus y equal to 1. I showed x plus y equal to 1. Straight line is false. I showed it is a plane. It is same as this place. Which one is right? You got doubts now. So many doubts you will get. Because x plus y equal to 1, you know it is a straight line. I showed it is a plane. Which one is right? Please. How far is Hyderabad from Vijayawada? Anyone, please? Approximately? Approximately, anyone, please? How far is Hyderabad from Vijayawada? Approximately, you can tell, please. Anyone, please? How many kilometers? Approximately, you can tell. Anyone, please respond. I want to correlate the subject, please. I am not elsewhere.
300, sir.
Around 300 kilometers. Very good. Very good. I am telling it is false. Because Hyderabad is not 300 kilometers. It is nearly 2,500 kilometers. 2,500 or 3,000 kilometers, I think. The reason is I have one more Hyderabad in Pakistan country. You may not know it. There is one city, Hyderabad, in Pakistan also. I am seeing that Pakistan. I am seeing the Hyderabad in Pakistan, not in Telangana state, please. My question is same. How far is Hyderabad from Vijayawada? You are thinking Telangana Hyderabad. I am thinking Pakistan Hyderabad. So what happens? Which one is right? There is a dilemma. Means every question has limitation. Every question has a limitation. Generally, we take Vijayawada to Hyderabad. Means Telangana Hyderabad, not Pakistan Hyderabad. Similarly, x plus y equal to 1. What it represents, somebody asks you, a person like me asks, then what your answer should be is x plus y equal to 1 is straight line. It is right. But if I ask repeatedly, does it right? Does it right? Immediately you should tell. You should tell like this. 300 kilometers from Vijayawada to Hyderabad is right. That Hyderabad is Telangana, you should tell like it. Similarly, x plus y equal to 1 represents straight line in 2-dimensional. X plus y equal to 1 represents plane in 3-dimensional. I think you followed my question. The correct way of speaking. X plus y equal to 1 represents straight line in 2D. X plus y equal to 1 represents plane in 3D. Here my intention is, please observe, ax plus by plus cz equal to d is a plane equation. It is a plane equation, please. You don't have squares, x square or y cube or z power 4 like it. Ax plus by, linear combination. Ax1 plus bx2 plus cx3 I explained previously, linearly dependent and independent. The same concept here also we use. Ax plus by plus cz equal to d is a plane equation 3-dimensional. Okay. Now x plus y equal to 1, it represents straight line in 2D. It represents plane in 3D. Now my question is, what it represents in 4D, 4-dimensional, in 2D straight line, in 3D plane, in 4D what it represents? What's the name of it in 4D? 4th dimension. Again, I want to ask one more question. Does 4D exist or not? Does 4th dimension exist or not? Anyone? Please. 4th dimension exist or not? I will explain all those to you in mathematics. Okay. Okay, now come to this, please. I will explain those to you later. Now come to here. X plus y plus z equal to 1. It represents a plane equation, okay, in 3D. Okay, I will come to the dimensions later after this slide. X plus y plus z equal to 1 is a plane equation. It represents plane equation. I am taking another linear equation. 2x plus 2y plus 2z equal to 5. Now, I have taken a linear system which contains two equations. Both are planes. Now, can anyone give x, y, z values which are both the equations? Is it possible? I need solution. X plus y plus z equal to 1, 2x plus 2y plus 2z equal to 5. Can anyone give the solution? Is it possible to give solution or not? Anyone? Can you give solution here or not? Is it possible? The second equation is nothing but x plus y plus z equal to 5 by 2, which is 2.5. In other words, give me three numbers. Addition is 1, at the same time addition 2.5, which is impossible. Means no solution. Both are planes, parallel planes, please, not parallel lines, parallel planes. It is impossible to give solution here. They are parallel planes. X plus y plus z equal to 1, x plus y plus z equal to 5 by 2, which is 2.5. They are parallel planes. Means no solution exists for this system of equations. For this system, there is no solution. Next example. The first equation is same. Now, I have taken the second equation, x plus y minus z equal to 5. Now, I need solution of these two. Please observe. To solve this, what I am doing is, I am adding both. I need solution. To add both. When you add both, z disappears. 2 times x plus y equal to 6. So, x plus y equal to 6 by 2, which is 3. Directly I have written. Adding, you will get actually 2x plus 2y equal to 6. Z disappears. X plus y equal to 3. Okay. If you substitute x plus y equal to 3 in either of the equations, now tell me z value. Please. Substitute x plus y value and z. Tell me z value. What is z value? Please tell me z value here. What is z value? Substitute x plus y and tell me z value in either of the equations. Please respond. I need your interaction.
-2, sir.
-2. Very good, very good. Please. What's your name, please?
Tejaswini, sir.
Tejas. Very good, very good. Please interact. Substituting, we get z equal to -2. So, I can give x, y, z, which satisfies the given equation is same as x plus y equal to 3 and z equal to -2. For example, I can give 1, 2. 1 plus 2 is 3 and z value -2. Please observe. Therefore, solutions are, I'm giving some more solutions. 1, 2 and z value -2. 1 plus 2 is. Another solution. X plus y should be 3. Therefore, 2, 1, z value -2. Not only this. X value 3, y value 0, z value -2. Or 0, 3. Like that, I can give many solutions for the given system of equations. Now, the geometrical figure, what happens? Please observe. These two are two different planes. They are not parallel. They are not parallel means they intersect like this, please. They intersect. They are not parallel. Then, all these points lie along the intersection line. All these points lie on the line of intersection of the given two planes. You have infinite points on this line. Means you have infinite solutions for the given system of two planes. Previously no solution, but here you have infinite solutions. Okay, next. The third example. X plus y plus z equal to 1, the same one. The second one, 2x plus 2y plus 2z equal to 5, means example 1 only I have taken. But The third one is different. I have taken three equations now. 3x plus 3y plus 3z equal to 11. What happens to the system? X plus y plus z equal to 1. Second equation is same as x plus y plus z equal to 5 by 2, 2.5. Third equation, x plus y plus z equal to 11 by 3. Three different values. So, to draw these three planes, those three are parallel. Means it is not possible to give x, y, z values which satisfies all the three. Means no solution. Parallel. The next. The first equation is same. The second equation is also same. These two are parallel. But the third one, x plus y minus z equal to, it is not scalar multiple. Scalar multiple. What happens then? Please observe. These three are placed. The first two are parallel. The third one is not parallel to 1 and 2. Then it looks like this. Two are parallel. The third one intersect. Please. Two are parallel. The third one intersect. Now how many solutions? I require x, y, z satisfies all the three. Not possible to give 1 and 2 automatically. No solution. It is not possible to give x, y, z. It satisfies 1 and 2 equations because these two are parallel. Hence, no solution. For two equations, I am unable to give automatically. I can't give the for third also. The next one, x plus y plus z equal to 1. The first is same. The second is x plus y minus z equal to 5. I missed this one, please. I am taking the second example, please now. But I am adding one more equation to this. To this, I am adding one more equation, please. 3x plus 3y plus z equal to 1, please. Now, what happens to this? The first two are like this. Please observe. The first two intersect in a line. The third one here not intersect in this line. It is parallel to the line of intersection of first two. First two intersect in a line. Third one is parallel to that line. A line parallel to plane, please. Why it is like it? Please observe. Here no solution. When we have like this, no solution. Two intersect in a line. The third one is parallel to that line of entry. This you can easily observe in second and fifth. In second one, x plus y should be 3 and z value minus 2. So when you substitute in third one, this x plus y is 3, means 3 into 3, 9. 9 minus 2, which is 7, but it is 1. But it is 1. So first two, x plus y should be 3, z minus 2. When you substitute here, you are not getting 1, means no solution. Means the geometrical picture looks like this, please. Next. Again, sixth example, x plus y plus z equal to 1. X plus y minus z equal to 5. Same as like this. Now, I am taking the third one, x minus y plus z equal to 1. What happens? Now, observe. It looks like this, please. Three planes. The first two planes intersect in a line. The third plane not parallel to line of intersection of first two. First two intersect in a line. Third one is not parallel to line of intersection of first. Line of intersection of first two, not parallel to plane. Not parallel means that line go through somewhere in this plane. That is the point. That is a unique solution. If you observe here, these are certain points of first two. Example 2 only. Among these, this 3, 0, minus 2 satisfies the third equation, please. 3, 0, minus 2 satisfies the third. It is the unique solution. If you take any other point, for example, 1, 2, minus 2 satisfies first two, but third equation it fails. 1, 2, minus 2, it is not 1, please. 3, 0, minus. That's a unique solution. Next, one more possibility I am showing to you. The first equation same. Second equation same. Third equation, please observe 3x plus 3y plus z equal not 1 now. Now I have taken 7. Then what happens? Please observe. It looks like this, please. Star shape. The first two intersect in a line. Example 2. These are the points. Now this x plus y equal to 3. Substitute here in third equation. 3 into 3, 9. 9 minus 2, which is 7. If x plus y equal to 3, z equal to minus 2 satisfies third equation. Means the solution of 1 and 2 is same as solution of 3. Means all the three planes passes through a line. Through this line, the third plane is also passing through it. You have infinite solutions. You have infinite solutions. All the three planes passing through a line. Infinite solutions. Those infinite solutions are these only. All these satisfy the third one also. For example, x plus y equal to 3, z equal to minus 2. Then the values 1, 2, minus 2 satisfies all the three. 2, 1, minus 2 satisfies all the three. 3, 0, minus 2 satisfies all the three. 0. Like this, you have many infinite solutions. Whereas among these, 3, 0, minus 2 satisfies the third. In example 6, only this one, unique solution. I explain different possibilities of planes. If you observe, when you are taking linear system with 2 equations, 3 equations with 3 unknowns. If you observe the possibilities, either no, 1 or infinite only always. A linear system always have 3 possibilities, no solution, 1 solution, or infinite solutions. Okay. Next, dimensions. Okay, dimensions. Does fourth dimension exist or not? Please interact. Then only I can. Otherwise, I will stop here. Dimensions. Does fourth dimension exist or not? Anyone, please? I want to discuss the dimensions. Please, I am not elsewhere. If you require the basic concept, all these, you will realize the importance of these basic concepts in bits. Once if you are strong in fundamentals, you can easily attack any bit given in GATE examinations. Without knowing what is dimension, you can't proceed further. 4D, fourth dimension, does it exist or not, please? Fourth dimension, exist or not? Anyone? You can tell your answer. There's no wrong in it. Anyone, please?
Does not exist.
Does not exist, okay? I will show it exists, okay? I will show it exists. I will show to you, please. Shall I show to you now? Observe it. I will show to you. First, I am showing one dimension. It is one dimension. I am showing to you. Now I am showing two dimension. 1, 0, 0, 1. Now I am showing three dimension. 1, 0, 0, 0, 1, 0, 0, 0, 1. Please observe, I am showing fourth dimension to you. Fourth dimension. Dimension 1, 1, 0, 0. Number 2, 0, 1, 0, 0. Number 3, 0, 0, 1, 0. Number 4, 0, 0, 1. I showed fourth dimension to you. Okay. I think you are able to show me fifth dimension to me. Sixth dimension to me. I think you are eagerly waiting for the picture. Okay. Are you waiting for picture?
Yes, sir.
Okay, right. I will show the picture also to you. Please, all of you, please pay attention on it. First, I want to ask certain questions. Please respond so that you can follow it. Now, I have drawn this. What is the dimension of this? Please tell me. What is the dimension of this? Please tell me the dimension of this.
One dimension.
One dimension. Right, very good. Now, tell me what is the dimension of this?
2 dimension.
2 dimension. Very good. Now tell me what is the dimension of this one?
3 dimension.
3 dimension. Okay. You are telling the dimension 1, 2, 3. Now my question is, okay, you are asking 4th dimension now. Okay. You are asking 4th dimension. You are agreeing 1D, 2D, 3D. Okay. Now coming to 1D, I don't agree the first one is 1D. I don't agree. The reason to me is you are drawing this line. Draw this line without width, without height of this color. Then only I agree. This is 1D. Please draw this line without width, without height. And also draw this line within 0 seconds time. 0 seconds time. And also draw this line without applying any pressure on it. 0 pressure on it. With a 0 temperature on it. Can you show? Can you draw this? Without width, without height and all it? Can you show that? Can you show 1 dimension to me without width? Please respond. Can you show 1 dimension to me without width? Can you show or not, please?
No, sir.
No. You cannot show me 1 dimension without width. Actually, you are showing a line, you are telling me 1 dimension to convince me. But I don't convince because it has width. So, you are unable to show me 1 dimensional. Followed without width. You are unable to show me similarly 2 dimension. You are unable to show me 3 dimensional. You are unable to show me 1D, 2D, 3D, but you are asking me to show 4D. How can I show? You followed my question. వితండవాదం అంటారు దీన్ని. మీరు 1Dనే చూపించలేకపోతే నన్ను 4D అడిగి నేను ఎక్కడ చూపించేది? I think you got the meaning? Okay. I don't want to argue like this because you require the argument power also, please. I will show really the 4D to you now. Okay. Now observe. Coming to 3D. Now observe this. I am taking the help of the windows. Now I am drawing these lines. Observe this blue color. Now observe this black color. I am taking the windows. You know windows symbol. Windows symbol. I am taking the help of windows to show you 4D. Observe this rose color I have taken. Now, what is the dimension of this picture? Please tell me. What is the dimension of this picture I am asking? Please tell me. I have drawn a picture.
3 dimension.
3 dimension. Very good. 3 dimension. How can you say it is 3 dimension? X-axis, Y-axis, Z-axis. But the board here is I have drawn straight lines. All are straight lines only. Please. I have drawn simply the straight lines. Drawing subject. Drawing subject. Straight line. Straight line. Straight line. Straight line on a board. Straight line on a board means the board is 2D. On 2-dimensional, you are accepting 3-dimensional. Means our senses, please, our brain accepting 3D on 2D. 3D on 2D. Actually, it is false. Actually, it is 2D only. Length and width only. You don't have height. But we are, our senses accepting 3D on 2D. Followed? So, all these are imaginations. Imaginations, please. 4D, 5D, 6D, all these are even 1D, 2D, 3D are also imaginations. Even 1D doesn't exist, 2D doesn't exist, 3D doesn't exist, or all exist. The best way, all exist in fact, the best way to explain without any error is mathematics subject, please. 1D, don't draw this line, 2D, 3D, don't draw this. I explained 1 dimension, 1, 2D, 1, 0, 0, 1, 3D, 1, 0, 0, I, J, K, like 4D, not IJK, I1, I2, I3, I4, I1, I2, I3, I4, this is 4D. Without errors. Therefore, the best way to explain dimensions is mathematics subject, please, without any error. All the pictures are just for our understanding, but with errors we are accepting with our senses, please. We require applications. For example, we are seeing the movies. Actually, 2D movies we are satisfied with 3D view. Actually, we have 3D movies also, but we are not. We are satisfying ourselves with just simply 2D movie by observing the depth, a box in a 2D type. Okay. Now coming to here, the practically don't think the fourth dimension is always time. For example, the applications. To describe the traffic in Vijayawada city, I require the place and the time. Means X, Y, the place. Z stands for the time. The third dimension is time there. Suppose I require the air traffic, aeroplanes traffic. I need the place X, Y, Z, 3 variables I need, 3 dimensions. And with the time also I require, at what time the plane is there. X, Y, Z, T I require. To describe air traffic, I need 4 dimensions. The place and the time. Road traffic, the place X, Y and the time T. Now I need the air traffic together with the wind velocity at that point. Wind velocity, maybe cyclone. So I need 5D. 3 variables represents place. The 4th is time. The 5th is wind velocity. The 6th is temperature. The 7th is pressure at that point. Like this, you can add independently. That's why independent vector. First one, second one, third one, fourth one, fifth one. Like this, please. All these are concepts, please. Okay. I think you realized the dimensions. Okay. With this, it's already across more than 5 minutes. I will stop here. Day after tomorrow, I'm going to explain the concepts. Some more concepts. Later, I will go to problems. Okay. I think you realize the dimensions. Okay. If you have any doubts, you can ask. Any general doubt also, you can discuss with me.
Ma, you can ask if you have any doubts, Ma. Okay, sir. Thank you, sir.
Okay. Thank you.
Thank you, sir.
Actually, I can go to philosophy also from this. Okay,
Okay, sir.
okay, right. Thank you.
Thank you.